Thank you for coming to the talk. Basically today I'm going to show you how to get yourself onboarded with Chronicle Oracles. Real quick, who am I? My name is Brian Belhumer. I'm the front-end lead at Chronicle. You can find me on Twitter, JSArtisan, GitHub, Brian Belhumer. My Telegram, I forgot to put on here, but it's the same as my GitHub. And I've got a blog that I haven't updated in a long time. So who are we? We started life as the first ever Oracle on Ethereum in 2017. We started inside of MakerDAO as technology that MakerDAO created to secure all their DAI vaults. So all the tokens that you can deposit into MakerDAO to mint DAI, our Oracles are tracking and making sure that everyone has healthy vault levels. Because we started inside of a true DAO and true DeFi project, we're verifiable, we're community powered, we're actually decentralized, blockchain agnostic as long as it's EVM based, and really cost efficient. So, really just a real quick overview about how our oracles work. All right? So we've got sources, price sources. We use high liquidity price sources to make sure that oracle manipulation is a very difficult topic. So we include Coinbase, Kraken, Binance, a few on-chain sources like Balancer and a few others. But mainly we get some high quality reputable sources. And then in order to pull those sources, we have enrolled the help of really high quality and reputable names in the industry, in the DeFi industry, including Etherscan, Gnosis Chain, Infura, and a bunch of others. I can show you more on the list later. So basically each of those independently queries the sources, gets prices, and then they cryptographically sign these price messages and they send them on the network. All right, so the relay will pick up these price messages that have been signed, verify the signatures are correct, and then when we have enough signatures for a given price pair, we bundle it up, we calculate a median price for it, we sign that cryptographically, and then we put that on chain. Now this whole process from the fees all the way through to the price that appears on chain is verifiable by you, and you can go and make sure that all these signatures are what we say they are. So the relays can push it to any of the chains that we support. Currently we have Ethereum, we have Polygon ZK EVM, and we have Gnosis Chain, and we have plans for a bunch of more chains coming up in the near future. So this is a QR code for all the info. So all the stuff that I talk about today, it's all linked off of this doc. So you can grab this here, so you don't have to try and scramble for it later. If for some reason this QR code doesn't work or you lose it or whatever, you can always come by our booth or just go to docs.chroniclelabs.org and then you can navigate to the Istanbul Hackathon pretty easily. It's not a lot of confusing things there. So how do you use our Oracle for the hackathon, right? How do you use Chronicle Oracle? First and most important, our oracles are access controlled. So you have to have access in order to use the oracle. So our auth procedure is called a kiss, right? And on testnet oracles, you can do it yourself. So you kiss yourself, it's called a self-kiss, on each oracle contract that you want to use. So each token pair that you have has a different contract address. So if you want to get the BTC USD price, there's one oracle address. If you want the ETH USD price, it's another address. If you want the Gnosis USD price, it's another address. If you want DAI, ETH price, whatever, and so on and so forth. I'll show you those lists in a bit. So for each contract that you want to use, you have to authorize yourself on that given contract on that given chain. So I'm going to try to do this live. If it doesn't work, I have a bunch of slides that are step by step, but it's a little nicer live. So we'll try that. Okay. So this is our docs. This is the link I gave you earlier from the Istanbul docs. So it'll explain, there's a lot of information about the bounties. We have a $4,500 first prize, a $2,500 second prize for projects that incorporate our oracles in innovative and interesting ways. And then there's a $3,000 pool prize for everyone that integrates one of our oracles. We'll split this prize. So there's details that we can get to in a bit. But basically, in order to get yourself authorized on a given contract, I'm going to do ZK EVM because that's what I did in the trial. You want to go to the self-kisser address, and that's the very first address on the list, right? So that's the most important address right now. Once you use this address to authorize yourself, Here are all the different Oracle addresses for all the different price pairs. So these are the different price pairs that you can get on ZK EVM. These are all the price, the self-kisser and all the price pairs for Gnosis mainnet. And then up here is the same thing for Sepolia network, right? So for here, you want to click on the self-kisser and it'll take you to the block explorer for that given chain, in this case ZK EVM. And then you want to go to write contract here. And then you want to go down to number 4, self-kiss. So the first thing you put in is the Oracle. Is this big enough to see? Or is that better? Okay. So there's 2 things that it needs. What Oracle do you want to be authorized on? And what address are you going to be accessing the Oracle from, right? So for the Oracle that you want to be authorized from, it's one of these addresses. So let's say I want the Aave USD Oracle. So I'll copy this address and I'll drop it right in here. So I want to be able to read Aave USD price on my contract. And then for the purposes of my contract, I'm just going to use my wallet address. Oh, and also a quick detail. You got to connect to Web3, go to MetaMask, say OK. So it's connected. I'm glad I didn't have to type in my password in front of everybody. So once you connect your wallet, this is the Aave USD address, and then what address are you going to be accessing it from? I'm just going to throw in this address because it's a valid address, but basically it's going to be your contract address of your hackathon project. So if you redeploy several times, you might have to do this several times unless you use like what is it called to, whatever the function name is to deploy your contract to a given address every time. So then you're going to click write. MetaMask is going to say, are you sure you want to spend this 1 penny of testnet ETH? And you say, of course, it's well worth the cost. And then, assuming that it goes through, now my address will be authorized to access the Aave price. And the way that we test that is we go back to this list and we go to the actual Aave contract on Polygon ZK EVM. And you want to go to the read contract. And again, this is all written down in the docs, so you don't have to remember every step. But I just find that if I show everyone how to walk through it, then when you read the docs, it makes sense. And then you want to make sure that you're told, this is number 19, and say, this is my wallet address that I just entered in the other one. And you're going to query, and it says true, which means it's true that I have access to read this Oracle. And then when you want to read it, you just use the read function with your contract. You get the price. A read with age will give you price and the age, the actual Unix epoch timestamp of when the price was created. So going back to my slideshow here, is this it? No, that's not it. Here we go. So I can skip past. I didn't have to use my backup. All right. So if you don't like doing all this stuff manually, you can do it, via UI. You can do it via CLI. So you can grab the self-kisser repo here. This is the QR code for it. And you can use cast and do it there. You can even do it programmatically if that's your thing. And it has instructions on how to do it as well. So how do you read from oracles? Once you've authorized yourself on the contracts, this is the Chronicle STD repo, and this is where you get the Solidity interface for our contracts. It's the same, obviously the same interface for every contract. Now I'll zoom in for you. And I'll go back to the QR code in a bit. Oops. No. So the 2 most important and interesting functions that you're really can be interested in are read and read with age. So read will just return literally a value. It's a uint value, and it's excuse me, 18 decimals of precision. So for the current Bitcoin price, it'll be like 36604 0.00000. 18 decimals. And read with age is the same value, but also includes the the age. Thank you. Sorry for all the coughing. I've been talking a lot at the booth, wearing out my vocal cords. And then, sorry. One moment. And then also, if you have contracts that can't revert for any reason, you can do try read and try read with age, and then also return the same values, but the first value will be an additional Boolean that tells you whether or not it's a valid read. So in the edge cases, some people have contracts that need to not revert under any circumstance, and so these two functions will not revert. But that's only in the edge cases. So read or read with age. So if you want these interface, you can either go to this GitHub and you can copy and paste it right into your project, or you can import it with Foundry if that's what you're using. Here's a QR code one more time, just for a bit. Just a quick note on naming convention. These are how we name all of our contracts, so you can check them out on Block Explorers. So for Chronicle, ETHUSD, base will be ETH, and quote will be USD, BTC USD, so on and so forth. And then the number at the end is the version. So I think most contracts are on version 2 right now. Some of them might still be version 1. But that's not really important for your purposes. The important thing is that it's the token pair that you're looking for. I want the price of ETH as expressed in USD. So if you need help, this is a QR code for our Discord. You can go on there. You can ping us on Discord. We're also going to be at the booth, today, tomorrow, Sunday. We're available to help you out, kind of help you through ideas, anything like that. We're happy to help you. I mean, it's very straightforward, very simple kind of interaction with our contracts. So if you have any questions on that, or how you might be able to integrate oracles, or how it works, or anything like that, we're happy to answer your questions. So we're available on Twitter, Discord, LinkedIn. Send me email for my information at the beginning. And now I'm open to taking questions for the next 17 minutes or so. Yeah.
Do you offer any type of registry to be able to find the address of the specific oracle that someone's looking for?
Great question. We've gotten that question actually more than once today. Not yet, but that's something that we are considering either doing via ENS named. You can just do like btcusd.chronicle.eth, something like that, or perhaps just doing kind of a registry contract where you do call read on that contract and just pass it the token pair that you're looking for. It'll do proxy that read to the proper contract on chain and then just return the result. But currently, no. You have to call the contract address directly right now.
And does the oracle itself know the token address?
Yeah.
Right, and it's able to return that as well?
No, you'll know the token address related to the oracle, because each oracle has its own address. So usually people do a struct or a map when they put like BTC USD, this is the address, so they can know what token they're talking about.
The oracles are not for contracts for ERC20s or like any ETHGlobal. They are actually for the price. So this contract would be anything. It's usually that they are ERC20, but not only. So
I see.
So
Yeah, it's not exclusive to ERC20 tokens.
yeah.
Yeah, or we also have one contract that's the IBTA is a iShares Treasury Bond ETF. So you can track the price of 1 to 3 year United States Treasury bonds. Yeah. Any other questions?
Yeah. To be sure, you only pass Oracle, not for off-chain events, but
Yeah, right now it's just on-chain. So basically, you can call the contracts on-chain. We do have the data available, but not as a product off-chain. So if that's something you're interested in, we can talk about that afterwards.
Can I ask about the feeds? Like the difference to oracles feed is basically this thing between the source and the actual oracle.
Yeah, let me show you the dashboard. It might help your understanding a bit. So.
My main question is like, what is the address of the feed? Because like, if you actually try the address of the feed, there is like no contract.
Yeah, so these feeds have all been onboarded by MakerDAO governance. So you can verify the feed address in MakerDAO governance forums. So that's where like you can verify. Because otherwise, generally, no, the feed address isn't doing anything beyond being a verified, like a verifiable address.
So our vocabulary is a little bit different. Feeds are off-chain EOAs. Are EOAs, they are not on-chain. And usually I have seen in many documentations that people call them what we call oracles, they call feeds. Oracles in our like terminology are on-chain contracts, and feeds are the validators that do that just sign. Just is a very important part, but yes, like, and you see, these are reputable projects that they stake their reputation that everything's so okay with that. This is the like biggest one.
So these addresses are different from the ones that you put in voice, like when you keep going to the keys thing. Right?
These are feeds these are signers. Only.
Yeah.
The contracts are different addresses. You can see them in the documentation.
So to GIS, like the GIS thing is just for to be able to consume the data.
Yeah, to consume the data.
It's
Exactly.
like one of these addresses.
No,
Yeah, these are the addresses of the data providers, basically the feeds that cryptographically sign the data that verify like, hey, I as Gitcoin or I as DeFi Saver or Etherscan verify that this is valid data, putting it on chain. So they put that on our feed network, and then we pick that up with relays and then submit that information on chain. And because it's all cryptographically signed, we can see that like you can be assured that the data came from the sources that we say it came from, and therefore it's verifiable all the way through onto the chain. Sure.
Is there a way to access historical data from oracles?
Not on chain currently. It's only current price, but we have all the historical data available. Actually, yeah. If you want to do it on a contract, if you want to do it via RPC node, you can. You just walk back the chain and see with the call data. It's all technically there, but in terms of accessing it from a contract, it's current price only. Cool. Any other questions? Yeah.
Well, in relation to that, does that mean it gets updated every block or every certain amount of blocks, or does it get updated when the actual call is being made?
No, it's a push oracle, so we update it at our intervals. So, and it depends on it's oracle, so it's on a per oracle per blockchain basis. Most of them are set to these thresholds. So if there's well, actually not this threshold. This is 4%. Most of them are set to 1% or 24 hours. So if there's a price deviation more than 1%, or it's been over 24 hours since the last update, we update it. But basically, it's just updated at intervals that we set. So yeah, real quick, I can just show you real quick since we have a few minutes remaining. So for a given price, say this is the current BTC USD price, you can go down and you can see these are the 13 feeds that were involved in creating this price. So it takes all 13 of these feeds, it sorts them in numerical order, lowest to highest, and then it takes the median price, which is, as you know, the middle price. So for example, this DeFi Saver price, DeFi Saver sourced its information from Coinbase Pro, Kraken, Bitstamp, and Gemini. And if you click verify here, you can see that this is the price message that DeFi Saver sent to us, verifying the price that they calculated from those 4 sources. This is the median price that they calculated. The age is when they calculated this price. What is the token that it's calculated for, and then this is the RSV of the ECDSA signature. So you can verify this ECDSA signature does in fact match up to the DeFi Saver EOA address here. And then you can also go on chain here and see on Etherscan, this is all the data that is put into this oracle. So you can see these are the 13 values in order, these are the 13 ages in order, and then these are the 13 signatures of those feeds that provided that data. So if you want to manually do it, you can manually do it, or you can use our handy tool on our website over here that does the same thing for you. But basically it's all verifiable data, and you can see exactly where it came from, who it came from, how it got there, and how we calculated this price. So that's really one of our main advantages, having come out of Maker, is we put a very high value on verifiability, because that's really the nature of DeFi, right? It's not trust us, we'll take care of it, because if you like that, just go to TradFi, right? So this is where we get our data. This is how you can verify it. You can link out and see all the different bits that go into making it happen. Any other questions? No? All right. Happy building. Appreciate you coming out. Thanks a lot.